Okay, Ellie, this is me re-recording the very end of class as it took it 15, 20 minutes to save the previous section. So I'll try to hit a few things. I know the last video kind of got soft at the end as well, so I'll hit a few things. Basically, we left most of the integration for you all to look at. It is mixed up between a variety of U substitutions, and then of course some of the fancier methods with integration by parts, trig integrals, etc. Hopefully you're actually pretty well on top of that kind of stuff since we just did it. I did talk about number 9 on your review sheet, which asks you to do the derivative of an integration. And if it asks you to do that, of course, you have to go, well, okay, derivative of integration, those are opposite operations, they should cancel each other out. So even if I give you some hideous, awful function that is impossible for you to integrate, it doesn't matter, except I should be putting a different variable in there. You can go, well, hey, if that's the case, if I actually integrated this, I would get a function that's all in terms of x's once I integrated it, and then I'd be doing the derivative of it. We know those two cancel each other out, so all you actually have to do is replace all the t's with x's because you're going to get the exact same function. So you should look at ones like number 9 as easy ones to do. We also then talked about number 10, average value. You may remember average value more as phase, F average. When you do the average value, I have the formula up here, which was simply 1 over b minus a, in other words, the difference in your two limits, and then the integration from a to b of that function. Visually, what it did is, you'll notice this picture I have down below, it asked if we know when integration will find us the area between the curve and the axis. So the yellow area is the area that integration will get us. What F average is just this y coordinate over here on the side, that if I drew a horizontal line across there between A and B, that rectangle should contain the same area as the area under the curve. It's a wonderful theoretical thing that mathematicians get all excited about. I also mentioned that I will be asking you on the test, the first thing, to write me what integration represents and what a derivative represents. So hopefully those are still tip-top in your memory, and we know, of course, that integration represents the area between the curve and the axis, and that derivatives are the slope of a line tangent to a curve at a given point. At that point, we went ahead and stopped because we only had a few minutes left of class, and we really didn't want to get rolling on area and volume. So what we have left for next class is to do area between two functions like top minus bottom, right minus left, this method, shell method, and then we need to talk a little bit about the differential equations where you solved for C, and I need to remind you about the formulas for work and fluid force. So if you have any other optimization questions, don't hesitate to come ask me about them, but they thought the one review did enough, and then if they had other questions, they'd catch me later. Have a good weekend.